Welcome back, everyone. We are here today at the last session of this track at DevOps Pro Conference 20. We have Mourek, development advocate at Igninga.
Isinga.
Izinga. I'm sorry about that. Over to you. You're going to have the discussion with streamlining your projects with Git, right?
That's true.
Wonderful.
All right, let's see if I can get this all set up. Share your screen. Then the correct screen. And oh, it was not the correct screen.
Yes, your screen was
There we are. This is the screen that I want.
wonderful.
All right. So for the last talk, I'm just gonna start in with a little graph to open it up. So there are a lot of different version control systems, but nowadays, when we look at the current repository usage in the open internet, Git is leading by 70% or over 70% of repositories, and the tendency is rising rather than falling. So um, let me check. Can I actually use my polls? I don't think I can. I mean, I had a poll prepared for you to answer what your version control systems are, but I guess I'll just skip that step. So yeah, Git is an important part of being in the tech industry, of developing software, managing configuration, and that's why we're talking about streamlining your projects with Git today. Um, so compared to some other talks that I've seen, this is probably going to be more of a beginner's level or an easy level to just ease you out of the day to day. And before we hop into the whole topic, I'm just gonna start introducing myself. So my name is Mourek. My pronouns are they, them, and I've been in the industry for not too long compared to some others here. I've started working in tech in 2016 as a developer for 3 years, where I've also started to actively use Git. 2020, there's been a bit of a shift, so I've started working as a developer advocate for Isinga, where I do stuff like bringing those talks to you, but also doing Git and GitLab trainings, which I started in 2019. So most of the focus around my work is on monitoring with Isinga and version control systems with Git. I'm super passionate about teaching accessibility and inclusiveness. So if you want to hit me up after the talk or tomorrow, feel free. My Twitter handle is at the Foy if you want to follow me. And since there's a lot to talk about, but not enough time, I'm just going to start right with the agenda. So, first of all, we want to talk about learning about Git, where it comes from, where it goes, how to work with Git instead of around, because that's a thing a lot of us do. Just hack in the commands, be angry about what it does, and, you know, just hit it with a hammer. Then I want to talk about which workflows might fit you, as in you as a person or you as someone in a project, maybe someone managing a project of a certain size. And in the end, I want you to take with you how to share this knowledge, or in general, share knowledge about Git with your colleagues, with apprentices, or just people that you want to teach. So, learning about Git. Well, first of all, what is Git? I mean, Git has been talked about a lot in this conference already, but starting out, Git is a version control system. So Git wants to help you figure out what the stage of your project was at a certain point in time. So you start with nothing, you add your first files, and then it continues to track everything that happens, which makes it easy for you to jump back to a certain point. May it be a release, may it be a point where a bug turned up, and to easily navigate and fix up what happened after. And to understand how Git can benefit us, we might want to look at where it comes from. So Git originates in the Linux kernel development, where at some point there has been a bit of a controversy with the version control that they've used before, and they've just started to do their own thing and develop Git. And by looking at the context in which it was developed, we can learn a lot of positives about it. So the kernel development is a massive project. And Git, therefore, was built with the intention in mind that big projects can be handled with a certain reliability, with a certain stability, and also with a certain speed behind it. The kernel development was obviously done on a lot of different distributions and operating systems. Therefore, it was important that Git would run pretty much everywhere and could run everywhere. And since a lot of people are working on the project, Git also is designed to help you work on different parts of a project at the same time. So having different teams focus on different aspects in a project. And with that in mind, we can start looking at how to learn Git effectively. So we want to start small, look at tiny pieces that lay in front of us, try to understand them and move on, because Git itself is massive, it's complicated, and there's no way we can just understand it all. So we need to take it step by step. And I would really advise you to practice your Git on the CLI. A lot of you are probably using Git on a daily basis already, and a lot of you will be doing that in a graphical tool. But in order to optimize your workflows and in order to fix things up, or in order to be able to fix things up quickly when something goes wrong, it helps to practice using the commands on the CLI and to understand how to fix up difficult situations. Then again, you might be asking, there are so many commands on the CLI to know, there are no buttons. I can't know them all. And no, you really can't, and you don't have to either. The important information or the important tidbit behind it is that if you practice using those commands and learn how to navigate on the command line interface, it's going to be a lot easier for you to understand how your user interface, your graphical one, works. And if you know what you want to do, it's very easy to look up the commands behind that. So try to understand how things work and then use that understanding to look up what in specific you need to do. And as I've said, we're going to start small and build up from there. So first we're going to look at commits. I mean, everyone's probably heard of what a commit is, but you can understand a commit kind of like a snapshot. So you start your project with a file, and the first commit will be the content of that file. But in order to advance the project but not bloat your whole repository, Git will only save the character for character difference between the commit that came before and the one that you're making now. So Git only saves the differences and is therefore able to go back a long while without having a super bloated file system behind it. And the commit contains some general meta information in the sense of you have your author name there. It's very important to have both your author name and your author email configured on your device before you make a commit, because this way others will be able to see that this commit has been yours. Or the other way around, if you see a commit that you don't understand or you want to ask questions about, with the author you can find out who wrote that commit and contact them for more information. A commit also includes the time when it happened, so when you made that commit. And it can also include a message with descriptions and references. So every commit will always contain a subject line, which is to be kept short and concise, so it's still readable and understandable afterwards. But in addition to that, you can also add a short description if you feel like it is necessary for others to understand what your commit does. And it also can contain references, which can be super interesting if you use enterprise suites like GitHub or GitLab, or also a Jira integration, for example. So you can add your references to your commits directly, so you don't need to bloat um, your repository, your commit messages, but instead you can just reference a ticket from your ticketing system where all of the history and all of the details about what you worked on can be found. And a commit always contains a pointer to the previous commit, so the commit it is on top of. And that is a very important piece of knowledge. So every commit has a commit that came before. So you have kind of like a pearl necklace where each pearl has a string attached to the pearl that came before it. And the integrity of the whole thing is basically maintained through the fact there's always a before, and this will be useful later. So a commit is one of the points in the commit history that looks a bit like a pearl necklace and is used as, a snapshot of sorts. So you know what a commit is, but what is a good commit? In order to have your commit done well, you need to configure your name and email. And one commit should only contain one topic. So if you've been developing a new feature, or if you started building up a new set of configuration, then you should make sure that your commit only contains one topic. That means if I developed a new feature for our user interface, I want to separate different steps in the development process into different commits in order to be able to figure out if a bug turned up, at which point exactly that happened. In order to do that, you sometimes need to split your commits, because if I develop a feature, I'm going to try to code out everything I do for it. And then afterwards, I look at it and see the different steps that I've taken and split the commit up. So make separate, smaller commits. And that also helps you to keep your messages short and precise. So you should try to aim to be under 120 characters, because that is the length that you can still skim through line by line and understand what's in the message without taking too long. So if you have a long commit history, you want to be able to skim it with your eyes and understand what each commit does. So how do I split my Oh yeah, sure. And add the references if you can. So add your reference to your ticketing system, because this will help connect your ticketing, connect your project management to your code base a lot easier. Oftentimes, if you're using GitHub or GitLab, they will automatically render a link to the ticket itself if you click on the commit, and the other way around in your ticket. If there is a reference in the commit will also be linked into the ticket, into the issue. And going back to splitting your commits, it's really good to use the staging area. So the staging area is part of the 3 stages model that you're having in Git. I brought you this little image where we separate between the local machine and the server. And what we want to be looking at with the 3 stages is our local machine. So we have our working directory, which is basically the files on your file system. This is what you're actively working on. We have the staging area, which is all of the files that you have prepared and handpicked that are going to end up in the repository. So to easier visualize this whole system, you can think of the real world. You can think of your desk that you have in front of you. So imagine you have a bunch of pieces of paper in front of you, and you're writing some new recipes on them, for example. So you're writing some recipes down, and then when you're finished with that recipe, you put it in a binder that's on your desk. So you take all of the code or the configuration, the writing that you've produced, and you put it in that binder. And that binder is the staging area. At any point, you can also take pieces of paper out or change something and then add it back in. And whatever you have in your binder, whatever you have in your staging area, is basically a preview of what is going to go into the repository as a commit. So in order to commit your changes, you're going to take that binder and seal it. So with the commit, you seal your binder, you seal your prepared documents, and then you put it on a shelf with other binders. So without that staging area, you would just take your loose stack of papers that you have on your desk. Maybe there are some notes on there as well, or things that you do not want to have in your neatly organized binder system. So using the staging area is basically keeping your stage that you want to have saved in your repository in a separate little box so you can overlook it easily and don't accidentally push anything that should not be pushed, like passwords, for example, or just general note files that you have laying around, or things that are not ready for the public. So all of this has been on our local repository on our desk. And the only thing that ever gets synchronized with the server is that stack of binders, is our local repository. So our working directory, our file system, obviously never gets synchronized with the server, and neither does the staging area. So that's a local helper for you to handpick what you want in your commit and what you want on the server eventually. And hopping on to the Git branches. Branches are also something that you've probably heard of before. A branch is basically a string of history. So a commit that follows a commit that follows a commit, and that last commit gets a name. And that name, for example, our main branch, is a pointer to the current commit or the most recent commit in that history line. So if you try to reference the most recent commit, you can just do that via the name of the branch. Those branches make it possible to freely switch between different states of the project. It's nothing new. If you have a main branch, or if you have a production branch, for example, for a customer, you can just switch between them and it will magically switch out your entire directory in front of you and all of the files. But it also makes it possible to develop different features simultaneously. So if I have my main branch with all of my current stuff in it, I can just switch over to a different branch and develop a feature without affecting the main branch. And in the same space, a colleague of mine can also develop something on a different branch without interfering with me. But more about that in a bit. Basically, having those different branches enables you to do things simultaneously. But in order to actually have a smooth workflow, you need to have some models behind it, some system on how those branches work. And those systems are what we're going to look at now. So I'm going to start building off from a centralized workflow. This is the easiest kind. This is made for small projects, for, I wouldn't say more than 3 developers. So it's 1 to 3 developers. I personally run a cookbook at home for me and my partner in a tiny little centralized Git repository. And it's also all right if you do it in an asynchronous team. So if you, for example, work in Europe and your colleague works in the States, and the time difference is so huge that you probably will never be working on the project at the same time, this is also a feasible case. And what this workflow basically says is that you're all working on a single branch on the same branch. In our case, this is going to be the main branch. So what happens is that there is a server, of course, that has the branch. And you on your local machine have the exact same branch and you start developing on it. In this case, on our local main branch, I added a new commit. And at the same time, my colleague, for example, or my partner added a different commit and synchronized that one with the server. So in this case, we're going to start having an issue because the server branch has a different history than my branch, and I can't really get them back together. In this case, what I have to do is a rebase, so I need to change the base of my branch to the one that's been on the server. So I temporarily detach my current commit, synchronize the server version of the main branch down to mine, and then I add my commit back on. I can synchronize that with the server again, and it works. This is by itself not a very complicated way of working, rebasing and adding a new, like just making those branches even. It's not too much work to do once in a while, but if you have to constantly do that with every single step you take, it's going to be very time consuming. And since you oftentimes have to manually sort out your files, it can be very, very annoying if you have to do that on top of the work that you're already doing with your commits, with your development. So what's cool about the centralized workflow is that it's super simple, it's super fast if you're working alone or undisturbed, and you can just add commits after one another. The problem is, if you work with colleagues together at the same time, there will be a lot of conflicts. After every single step, after every tiny commit that you're trying to synchronize to the server, it's probably going to be either you or your colleague that has to manually solve the whole thing. And another big problem is why you should probably not use it in actual projects at work is that you possibly have broken code in main, or rather that you most likely will have broken code because you make your small tiny commits, you're during development, and you push all of that to your main branch. So there's always half finished features in there, and that's not really what you want in your production. So to improve on that, there's the feature branch workflow. The feature branch workflow is suitable for medium projects of, let's say, up to 30 developers where it's still very feasible. You can push it further, but that's the sizes that I usually see in my trainings using that. And here the change is that the main branch only contains completed features, and all of the features that are being developed in their own branches. So the feature branches basically work like a centralized workflow. So you have your feature branch, that's where you do your development, you push your commits one after another. But since it's your feature that you're working on, it's very unlikely that you're going to run into issues with your colleagues a lot that are working on the same feature, because they'll be over on their own feature branch. And once the feature is completed, then of course it has to go back to the main code base. And that's where you'll have your merge. To illustrate that a little, so we have our main branch again, and I'm going to start developing a feature. So I open my own branch, add a commit, add another commit, and that's where I'm at. In the meantime, the main branch has grown, someone else has finished their feature, someone else has started their feature somewhere. Those slides were in reverse. But basically, everyone works in their own branch and will not disturb each other with their commits. That only happens in this phase. So you see, I have finished my feature, and this is also the point where reviews can happen. So that's also a big pro in comparison to the pure centralized workflow, where you have a finished feature and you can ping your colleague or have your processes surrounding it, where you have your code review, see, does this work? Does this fit? And if it does, it can go into the main branch. If it doesn't, you just add more commits on top. So I have added my code to the main branch, And once my colleague is done, they can add theirs. And we have added 4 commits or more, but we've only had 2 points where we need to merge in. And at this point, we have a working master, a working main branch, sorry. But we still don't have releases brought in here. So in order to mark releases, we can set tags. More about the tags later on, but basically what we can do is mark or stamp certain commits in our history to be a specific version that, for example, continuous integration and continuous deployment can hook onto and work with. So to the feature branch workflow. The pros are definitely that you have a stable main branch. So there's only completed features. There's nothing that's being developed right on the main branch. And since you have multiple branches where people work by themselves, there's a lot less interference that you have with others. It's also good for reviews, as I've mentioned, because you try to finish your feature in your own branch. And once you are at a point where you say, yeah, this is good, this is fine, you can start a review process and make sure that it's run through before pulling your changes back into the main branch. The cons are that there needs to be a lot more communication than in the centralized workflow, because you can no longer see what has happened in the meantime on the branch that you're working on, because you are secluded on your own branch and you don't know what has happened on the main branch or what is happening in other people's branches. So you need to communicate what's new. You will sometimes need to look at the code changes that are happening in the main branch in order to continue your own development. And you don't really have a release-ready main branch. So we do have a stable one now, but we do not have a branch that only has release versions on it, or when I can count on, I check this branch out, I have a release-ready version. That's not the case, because there's always the next developed feature on it. And the last workflow that we'll be looking at now is a step up from the feature branch workflow again, and it's called the Git flow workflow, which is basically an extended model of what we have had before. And it's meant for larger projects. So there's a lot more overhead than compared to the ones before. But it gives you a lot of structure and complexity and nuance, yes. So what we have now is our main branch, which is set to only contain released versions. So version .1, version .2, version 1.0, and there are no other commits in the main branch except for the finished releases. So whenever you check out the main branch, you know you have a released version or a release-ready version. And what has been the main branch before is now our develop branch. So the develop branch only contains completed features, but there is still the development being done there. So you still don't have your, let's start over. So on the develop branch, you basically have your completed features. And as before, from your develop branch, you get your feature branches that come off it. So all features are still developed in their own branches, but instead of coming off the main branch, they are now coming off of the develop branch. And as soon as a feature is finished, you can have your merges, you can have your reviews, and it will come back into the develop branch until you are at a point where you're ready for a release. So another branch type that you have is the release branch. as soon as you are at a state in your develop branch where you say, we are feature complete, we are ready for our next release, you can then branch off the develop branch. The development there can still go on. So you are not at a point where you need to stop and drop everything because you're going to prepare your next release. You can still do new feature branches, merge them back into the develop branch, but the release is fixed on a certain commit there. And in that release branch, you can do all sorts of release preparation, whatever you need to do for that. And in the end, when you are ready with your release, it is being merged into the main branch where it gets its tag. So CI/CD can run from there on. And it's also being merged back to the develop branch, obviously, because you want to have all of the current code, all of the released code back in your development. And since nothing ever works predictably, you also need to do some hot fixes sometimes. Let's say you found a security issue or something needs to be fixed in order for the production to continue working. There's also the hotfix type branch. So if you find an issue in your released version that needs to be fixed immediately, you don't want to go off the develop branch because maybe there are new features in there already that you don't want to bring into your security release version. So the hotfix branch comes off of your main branch of your last released version. You do your fixing there, you merge it back onto the main branch where it gets its new version number stamp, its new version number tag, and then the hotfix is merged back into our develop branch, so the code is ready for the next release or is in the branch for the next release as well. So as you can see, it's very colorful, it's rather complex, but it makes it easy to have that structure and to have your very organized workflows. So you know when you start a feature, you're coming off the develop branch, and you can also specify that, for example, certain people are only allowed to work on certain branches. So if you have a trainee, then they're only allowed to branch off the develop branch to do their features. And you can also basically lock in that release branches can only be opened by maintainers, for example. And the fact that you have, for one, your release ready main branch and your tags on the main branch, it's rather easy to automate, to start testing on it, and to start building automatically as well. Negative points are, of course, it's a very, very complex system that might need to be overlooked by a person that does nothing else in the project but check that everything is working the way it's supposed to. So you have the possibility of being very organized, but you also have the costs of having a organized and complex system. And the last bit of the talk is going to be about how to teach Git how to push that knowledge further. So Git is a complex tool, as I've said before, and you need to take your knowledge step by step. So now you've looked at different things that Git are made of. So you've looked at commits and what they consist of. And the next thing you might want to do is look into the commands that you need to use. And then the next step would maybe be check out what kind of flags those commands have and what those flags do, just to step by step explore what Git can do for you. So the important thing is never to try to dive into deep, but maybe go through the different things that I've talked about today and then take it by very small steps and see what you can discover. If you teach someone how to use Git or how to do a special operation in Git, and they have a question or they have an issue, try to solve it together with them. Do not tell them the answer outright, because it's probably not something that they will be able to remember. But what I found works a lot better is if you try to solve that question together. So in my trainings, oftentimes there would be questions about how do I show this and that, or what does this flag do for this command? And even though I might know the answer, I usually try to look it up together with the people that asked the question. So I will share my screen, I will go into Google and look it up, or use the command line and use the man pages to figure out what it does. And if you show your workflow of how do I figure out how stuff works, you're helping your trainee to figure out how to solve a problem by themselves without needing to ask you for everything. And while looking up things, I can only suggest that you look at the official Git documentation, because it is super, super, super useful. For each command, there's its own page which describes use cases, examples of how to use it, different flags, and also tips and tricks on what kind of operations you can do that you might not have thought of while looking at the command itself. And I also find that the official documentation is structured in a very step-by-step and very thoughtful way. So the way I learned Git back then was reading the documentation from start to finish and trying things out. So if you or your trainee is in a position that they need to start learning Git from scratch, try just working through the documentation, because that can help you a lot. And try to explain how things work with real life examples. So the example that I've used with your desk to understand the 3 stages can both help your trainee to understand how it works, but thinking through mechanisms and trying to figure out a real world counterpart can also help you understand a lot better what is happening, because you're trying to look at the materials from a different perspective, and that gives you more insight on how that could work. um, Another thing of, or another way that I used to explain the 3 stages was with a cookie jar, where you put cookies that you've just freshly baked into a jar, and you can select what kind of cookies go into the jar, which you can take some out of the jar again, and then in the end you can seal the jar and put it to the other jars. So trying to explain things with real world examples will not only help your trainee, but also help you figure out how things work. And I mean, you work in tech, you probably know this as much as I do, but your search engine is your friend. I don't think there's anyone who can say that they know every command or every way of doing things. And figuring out how Git works is definitely very, very strongly coupled with how well you can use your search engine. So I've tried to end this talk 5 minutes before the session ends, and it sort of worked out. So thank you for being here with me. On the slide, you can see my Twitter handle, the GitHub repository for our Git and GitLab training. I can see the irony myself, yes. And also the link to where you can find our trainings, just in case you want to hear me talk about Git some more. So thank you very much for being here.
Thank you. Before we conclude, we have a question. Let's take that question. That one.
Yes.
So I'll read that question. The point about learning the CLI is good, but what about just wanting convenience? Example, staging separate chunks or even lines to make commit only from a part of working copy, which is infinitely easier by clicking a bunch of stuff in or all the like Visual Studio Code, whatever. So,
Hmm.
what's your comment on that?
Um, I do agree that the convenience is hard to beat. I also use CLI tools on a lot of my projects. The thing is that if you start working with a CLI, even just a little bit, you'll figure out things that you can do that you cannot do, that are physically impossible to do in most UI implementations. So you can still commit line by line in your CLI. And the thing is, if you work on the CLI, you'll pretty much always be at the newest state of it, whereas the UI components might need some time to implement the new changes. So, sure, it's the most convenient option for day to day use. I do it as well. But sometimes I do like to take the time to figure out how things work on the CLI. And yeah, you have, in theory, more options if you know how to use them. I can't hear you right now if you're saying something.
So the next topic is one of my favorite topics. It's about rebase. You mentioned
Yes.
you do not like rebase. Can you elaborate a little bit more?
I mean, liking or not liking rebase, I think that's just personal preference. What I mostly meant in the workflows chapter was that rebases cost a lot of time if you have to do them very often. Um, I think you're referencing the chapter of the centralized workflow where I said you need to constantly rebase against what your colleague did. Um, so especially if you're working on files that or on the same file or in aspects where Git cannot automatically resolve it, and you need to manually fix up your current state of the code all the time, it's going to be very, very, very time intensive. Generally, if you work in feature branches and are at a certain point where you want to get a fix that is in the main branch, for example, a rebase can be good, a rebase can be very good. It's just doing it constantly after each commit is more time consuming than it's beneficial. Did that answer the question?
I, thi- I think it did. It was more of a comment and trying to get a bit more opening up from your previous comment. Yep, that's the questions from the chat. What I can read out. Uh, I have a question. I have a topic of conversation uh, which is related to Git, but not exactly Git. So ever since Planet Scale came out, uh, have you used Planet Scale? It's a it's a database that allows us to do branching. The concept of Git has been going beyond coding into different areas of software development. So, what do you think about that?
I mean, so the product that I'm the developer advocate for is Singer. We've also started using branching models for our configuration, basically. So in the Isinger director, you can configure a lot of things, configure whatever you want to monitor, basically. And it also has a new branching functionality at this point where you can have different branches of configuration. I think it's great because the system itself is a very intriguing one, where you can have one project but different states and figuring out, yeah, in which directions you can bring things and how to optimize things, especially also in the context of testing, for example, where you can have different branches that you can quickly switch between and see is this way the better one or is that way the better one? Which one is more effective? So I'm 100% pro branching.
Wonderful. We are running out of time today. So thanks for joining. It was wonderful. You went through a very large topic in a very short time. Amazing presentation. And thank you for all our audience who have joined today. It was a consistent participation throughout the day. Thank you very much. And yeah, we will close the day two of DevOps Pro Conference 2022 now. Have a great day. Bye bye.
Goodbye.